Good morning, team. Now it's 11 a.m. in UAE, so we are starting the session. So I'm going to introduce our trainer, Mr. Mostafa Saber, for the today's session for the BIM. So he'll start further. Thank you.
Hello, good morning, everyone. I'd like to thank you for this opportunity, and I would like to start the session with a brief introduction. So today's session is about using BIM for real estate, the progress that we can make with BIM through design, construction, and facility management as well. To start off, I'd like to introduce myself. Right now I'm working with X Architects as a BIM manager and a senior architect. I have a total of 18 years of experience in architecture and construction. I have also obtained my bachelor degree in 2004. I'm a certified Autodesk instructor since 2013. I've been teaching Autodesk Revit and 3D Max since 2011. I'm also a certified PMP since 2018. The agenda for today includes 4 main points. The 4 main points are a brief introduction about BIM, what is BIM and why should we use it. If you please, if you don't have anything to ask about, please mute your mics. Thank you. So the 4 main points are introduction about BIM, what is it and why we should use it, what are the benefits of BIM. Also the common workflows that we can use, the international standards that are available at the moment. And the second point is going to be the benefits of BIM in design, how we can use it for the creative design workflow, the collaboration techniques between different consultants and disciplines, and the documentation of design. The third point is going to be about BIM in construction, how we use it in construction and why we should use it, the difference between LOI and LOD. These are terms that we are going to explore together. I'm sure some of you already know about this. The site verification techniques that we can use on site during construction, and extracting as-built models. The last point is going to be BIM for facilities management, and that is including planning for success, how you can plan your requirements as a real estate developer, and also coding of assets, how you can code your different assets and different property components. Also linking BIM to smart solutions that we will talk about. With that, we are ready to start. So I'm going to start with the introduction about BIM. What is it and why should we use it? It's important to note that the examples here are provided, examples that we are going to discuss throughout this webinar have been provided by the Red Sea Development Company, X Architects, and Tariqa Ruqay. First of all, what is BIM, or why actually we learn about this BIM? BIM for everyone, it's building information modeling, and by building it means any type of project or construction. It could be infrastructure, it could be a normal building, a house, it could be a multi-story building. It could be residential, commercial, it could be a hotel, hospitality, retail, any type of building is included in this building type. So it's not only limited to buildings, but initially it was called building information modeling. Information, which is the middle letter, I, this is the most important part of BIM, and that's what actually makes it different from everything else. The information that we can get is information regarding spatial information. It can be information related to elements or systems, or information in form of schedules. That is all possible in information for building information modeling. For the modeling, of course, this is related to modeling of relevant site or architectural, structural components, MEP components, any component as part of the BIM model related in our project. The BIM process goes through all the phases of the project, and that is what we call the project life cycle. So it includes 3D information of building components, and that 3D information is linked to actual data that could not be graphical, could be just text or relevant information or links. And it is actually the successor of the technology that we used before, which is CAD, the computer-aided design tools. Now, when we come to why should we use BIM, and what are the benefits that we gain from BIM? The benefits start with coordination and collaboration. This is something that was not possible before we started using BIM. Before that, it was not really possible to collaborate in a meaningful way and in an instant way as well with your colleagues and other team members. With BIM, you can actually work not only with structure, architecture, and MEP systems and engineers, but you can also engage different architects on the same model to develop it together and make sure that the building is being developed faster in a more collaborative way. It also helps us with conflict detection and risk mitigation. When you see things in 3D and you have a better understanding of the building itself and the design in total, this avoids a lot of issues that could happen in the future. And that is what we call risk mitigation, because you can fix these issues along the way before it becomes too big and too hard to fix. It also has a high level of customization and flexibility. The components of BIM are not rigid. You can actually change it according to whatever requirements for your organization. And we'll talk about this customization actually in our webinar today. It also helps you with the optimization of schedule and cost, because you will definitely see this 3D information related to time, and that is what we call 4D simulation. It helps you with maintaining the building life cycle and making sure your information is relevant to each life cycle phase or component. So throughout the life cycle of the project, you will need different type of information. And at the same time, you'll be able to maintain the previous information that was in other stages required. It also has faster drafting without loss of cost or quality. That means that you can actually enable faster drafting, extracting drawings that you can actually use out of the model, and that does not compromise the quality and the cost of the process. In the next slide, we're going to discuss about components of BIM. What are the main BIM components? And I'd like to keep this organized in these four categories. The first part is the process. The process itself includes standards, the procedures that you can actually set according to your organization, and how you're going to manage the whole process throughout the project based on your terms or based on your actual role in the project. How you're going to manage information, what is this information required for, and that is what creates a process. The second part, or the second hand of BIM, is people. The people are, of course, the main component of BIM, and without them, nothing is possible. So it is important to decide who are the people who will be engaged in the software. Are they trained enough? Do they have the required skills? Do we need to give them training, for example, to gain additional skills required for this process? And do we have the required leadership and the collaboration spirit between them? Is it well understood between the people working on the project? The third one is going to be the policy. And policies could be mandated by government. It could be something that you have as a requirement by the owner. For me, as a consultant with my consultant and engineering background, I always have these policies and requirements from the employer as a red line. It's very important to understand the client requirements, what he actually needs and what he does not need, to make sure that I focus on what is required and relevant for the project requirements. The technology related is the fourth part or component of BIM, and the technology includes the infrastructure, the computers that you're using, which software are we going to use, and which version are we going to use as well. All this information is usually defined initially in the policies and processes that we are going to follow, which is usually identified as BIM execution plan or employer information requirements. These are all documents that will be part of the journey throughout BIM. Now, the common workflow that we usually follow, maybe you've seen this graph at the left before, and that includes mainly three items. I'd like to simplify them, as you can see on the right side: design, and then build and operate. The design includes programming for the project. What are the requirements, the main components, the areas required for the project? And then we go ahead with conceptual design, then detailed design, throughout analysis required for structural systems, for energy, for HVAC. All that analysis is required, and then we move into documentation, which ends the design phase. After the documentation of the design phase, we tender the project. The construction should start after winning the bids, and then fabrication could start. 4D simulation and 5D simulation could be involved, and 5D simulation is actually engaging the 3D information with time and money as well. So with time only, this means 4D simulation, and I will show you an example of this throughout the webinar as well. And 5D simulation is engaging cost related to the construction, and also the cost that you gain out of the construction. So it could be a two-way information that you're getting and you're recording in your BIM models as well. The logistics required for the construction, and the logistics required for the construction actually includes what type of cranes or equipment are you going to use? Have you planned the access for these equipment required? And using 3D information and BIM with 4D capabilities, it enables you to visualize these things and plan it ahead of time. The last part, or the last phase, is going to be the operation. And for operation, we could talk about maintenance and facility management, and also renovation, maybe at older stages and later stages of the project lifecycle. So that is, in brief, is the common workflow. There are certain standards that is related to using BIM in construction and design, and those standards evolved greatly in the past few years. So we've seen before the UK standards. We've also seen other standards from AIA, definition of LODs, and afterwards in the first quarter of 2019, we've seen a big improvement, which was the ISO standard. And the ISO standard is what is considered the basis for everyone working in the industry right now. All the big players working with BIM technology are identifying the standard that they use as the ISO 19650. And that was split into two parts. The part one includes the concepts and principles, while part two is focused on the delivery phase of assets and the detailed information included in this process. Now let's move to our second part of the presentation, and it's about BIM in design, using BIM in design, and how we use it actually from concept until tendering for the design process. When we start using BIM in design, it can start as early as this image, as you can see. It can be related to massing, if we're talking about massing for the project, studies for GFA and built-up areas related with feasibility studies as well. You can imagine actually that creating options like these and figuring out the impact on feasibility, the impact on the project cost for this such type of building is possible within few days, or let's say few hours. You can simply start creating simple masses inside programs like Revit, and then using this information, you can extract schedules like the one you see on the right side. It has area analysis, and you can also relate it to cost. You could simply start identifying the problems that you have in such plot, or the feasibility of building something on that plot. That alone could help you take decisions on what should be developed, what will be the final GFA or the built-up area, and what is the approximate price for this building. So we start using it very early at conceptual, for conceptual calculations. There are many benefits of using BIM in design. Benefits could be like this, for example, for site analysis. And if we talk about experience of site analysis, we like to do lots of models as architects. We like to study things in 3D. And this is actually a model that we have at the office in X-Architects. This model was created to study the levels and the relation between building components and the factors that we are going to consider while designing this building. This building is actually intended to be built in Saudi Arabia. It's a museum about Antara. I hope you've learned about this story, the impressive story of Antara in the past ages. So to study this, we started by creating models, but creating models alone as the old way of studying things with architects and to exchange ideas between architects is not the only way that we can use now with the capabilities of BIM. Now we can use the power of 3D scanning. And for 3D scanning, we can use drones, we can use handheld cameras. There are many ways to actually 3D scan an existing site. What you can see here is a 3D scan information of the site topography, and the main rock, as you can see on the left side. This is Antara rock, where he used to write his poets, and there are engravings on this actual rock that we are actually documenting now. So using the power of 3D scanning, you can extract information from a site that is thousands of miles away and gain that information into your design and proceed with the design process in the light of this very accurate information. You will be surprised to see that this information can be as accurate as millimeters. So the difference or the tolerance for mistakes is very limited. Compared to 3D models that we used before, this is a big improvement. We can also use the power of BIM for creative designs. At the left side, you can see a sketch that we created for this building. The building is mostly underground. Part of it is above, which is the stage where people will sit to watch folklore, theater, and performers. This massing was created initially as sketching and then converted into actual building components, as you can see on the right side. The massing for this is a bit complicated, and it would have been very hard for us to create this without the power of BIM. Also, to communicate our ideas and making sure that the slope of the walls and the inclination of certain features is well communicated in an accurate way with other engineers and disciplines working with us. For owners, there is a different benefit for BIM. As you can see here, creating a villa could be a challenging task as well, because the client does not have engineering background, most likely, and he would want to see information that is relevant to his requirements. So we can use the power of BIM to create colored plans that will emphasize the use of areas to the client. He will be easily seeing all the components of his buildings and able to take better decisions based on the light of knowledge. Also using 3D information and 3D plans, because some people are not really aware when they see a 2D plan what it means. Where are the windows, for example, or what is the difference between a door and a window? So it's more relevant to other stakeholders as well when they see 3D information that is relevant to their project and that is actually interactive with their layouts and plans that they can see. It makes it much easier for them to understand, maybe even walk through the building itself. And there are many ways to engage the clients right now with the usage of BIM. One of them is virtual reality, where you can actually walk through your building in a live walkthrough. How about designers? When we talk about designers, we're talking about smart objects for BIM. And that is different from what we used to create in the past. In the past, we were talking about 2D elements that the program actually does not understand what it is. We used to create lines and layers that is irrelevant to our industry. So an MEP engineer could draw a line. It could mean something different than an architect. For an architect, maybe these lines are a set of walls, but for an MEP engineer, it could mean ducts. However, the software does not differentiate between the line for ducts or the line for walls, as an example. Of course, we tried to work with this and created layers with colors and different pin assignment. However, the elements itself that you're using for the design process in the CAD process is totally irrelevant to your industry. With BIM, we have smart objects that are parametric. It has rich information, and it is 3D objects. And that means you can actually use these elements to render out your result and see how it works in 3D together. You can actually modify the size of these elements in most cases, change their materials because it's parametric. And parametric means that you can actually change parameters, a few parameters that will affect your model and the information that you're going to extract out of this. Also, it has rich information, and this means you can add information like who's the manufacturer for this, what is the cost for this specific element, and what are the exact dimensions related to this element itself. So we see now for designers what is the benefit of using BIM as well. Another benefit for designers is the improvement of coordination. And previously, if you looked at 2D information, it would be a bit hard, I would say, to find out what's the depth of a specific beam. You have to go through different documents to make sure that you're looking at the right information, and then do a few calculations to make sure that these beams are not penetrating the ceiling according to the level given in interior design or architecture drawings. However, in BIM, as you can see, the initial model that we create for the concept or the schematic detail, the schematic level of detail, is already includes all the elements that we have and already shows the problems that we are facing. And that means you can better visualize the ideas, communicate it with colleagues like other engineers working with us. And this means we can take better decisions and make sure that our building is better coordinated and take the best decision required, either to raise the roof or maybe change the structural design or adjust something in the architecture. Now, this happens with the help of something that we call CDE, the Common Data Environment. And the Common Data Environment, you might know it as BIM 360 or recently Autodesk Construction Cloud. This is a very smart platform that connects not only people who are working on the same local network, but also connects everyone working anywhere in the world on the same project. This means we maintain a single source of information. Everyone is viewing the latest information available. The collaboration is happening instantly. We can literally review throughout our meetings 3D models like the ones you saw in the previous slide, and take decisions immediately, ask someone to fix it, and then see the impact on other disciplines. We can also organize data in logical order and give access to those who need it. This means better control over the information of the project and making sure that you're exchanging the information with the right people. You can actually define roles and access to each person on the project. As you can see here, I have a list. Of course, the list is much longer than this for the project. And each team member has an assigned company role and assigned privileges that he can actually use. And this means you can actually set responsibilities and access per company or per role as you might see it fit. That is one of the best ways we're using actually to reduce the amount of time lost through meetings that could not be very meaningful without the use of this technology. The coordination that we're doing using BIM technology used to be in programs like Navisworks before. And this means you had to download the files that consultants are sending you and then link them together somehow, then start seeing what are the clashes or what are the rules for these clashes, and make sure that there are no clashes, or if there are any, you will report them to the concerned team member. However, this method is not the most efficient because you're using local information that is already on your hard drive. So someone could be changing the model right now, or you're reviewing a model that is 1 week old, that is old information. So it's not online solution. It doesn't have the capability of instant collaboration. And you have to set the clash sets and rules yourself. Of course, we do this with templates, with the help of templates, and we make sure that this process is as efficient as possible. However, it is not a mobile solution, so we cannot use it on site. And it's still required for certain situations. So we still use it on some projects. But right now, I would like to show you what we do with coordination right now. Coordination right now is immediate on the cloud. It's a very light platform, which I told you about is the Autodesk Construction Cloud. We can use this to immediately see the problems that we have and report them to relevant team members. I can immediately create issues, point out the problem that I can see, and write information related to this or comments related to the problem and send it immediately to the concerned team member to fix it. I can also give him a deadline that he has to fix this problem by this specific date. The last part of design is using the documentation quality of BIM. So we can use the 3D models that we have produced to create such drawings and create finishing schedules or any schedules required for the project to document it. The example shown here is for the same project that is Antara Museum, which is done by ex-architects. And these are the schematic drawings that is currently being developed into a more detailed package. Now let's go to BIM in construction. When we talk about BIM in construction, we're talking about quality assurance, we're talking about fabrication capabilities, how we're going to install things on site, and then extracting information for as-built models. And for that, I would like to show you the case study that we have for the Creation Study Museum, done also by ex-architects. The barcode at the right side has a link that will point you directly to the website of this project if you'd like to know more details about it. Now, moving forward about this project, we also created clash reports on site by the contractor that started studying the model and submitting his drawings to us in terms of NWD files, that is Navisworks native files, and drawings as well. So instead of reviewing a set of shop drawings by the contractor, you'll be able to review the shop drawings with the relevant models and clashes that are already there. And this means the consultant will be able to take better decisions and make sure that things are already coordinated before approving any shop drawing. The extraction of shop drawings is only approved after the approval of models that are clash-free to make sure that the contractor is following the same design intent that we requested and doesn't have issues of coordination that will come out as surprises on site. BIM implementation at this stage is done with the client in mind. And this is an example I'd like to borrow from the Red Sea, from my work with the Red Sea Development Company. So the client on this project is defining the actual file naming convention in a way that is relevant to the client and his team. This means we are going through a process that is already known. The end result is well known. We can see what is the end requirement or the end product that we're going to go with. So in this example, we have a program code. In that project, we have set of projects and we have a program that governs each of the projects. So projects are combined in programs. The originator code is a code that we have for each company working on the project. And I'm sure also Al-Futtaim has a similar way of naming. The volume is then used to define which type of building or which part of the building is it for, and then the level or location. XX means general, and then if we have multiple levels, it has a different code. If we have a specific level, then the number of that level is assigned. And then we write the document type, the discipline of this document, and the series number, which is previously agreed throughout the BIM execution plan. That part is actually received from the client, which is the Red Sea Development Company, in the form of employer information requirements. And then they also define not only what type of BIM models they will require, but also what they will use it for. In this example, we're using the information in the BIM models for authoring, design authoring. And this means we're using the models itself to extract the drawings that is considered design drawings. For this project, it was actually a design and build contract. And then we also use it for data classification. And this means when we use it for data classification, if you select any element in the model, you'll be able to see what is the actual classification of this model. Is it part of the doors, or is it a part of openings, windows, walls, structural elements? So the data classification is something that we can use according to master format or OmniClass. This project, it was OmniClass actually, to make sure that we classify things in the right way. We're also using the BIM models for 3D design coordination to make sure everything is coordinated. Design gateways, so we have an archive at each end of stage. So for that project, we had detailed design for the project. That is one phase. And then another phase for LOD 400, where we get the 100% coordinated models with defined manufacturer and making sure that it is relevant to the manufacturer information and size of equipment. So we create an archive at each stage for the BIM models. We also use it for data validation and quality assurance. Sustainability evaluation is also part of the process. So we use these models to create energy models and make sure that the building is meeting the standards required for such project in terms of sustainability. We're also using these models in that project for as-built and recording the final state of the models. The last part is asset management and planning for maintenance. And this is really very important when it comes to these two elements. We'll talk about these more into detail, and I will show you examples of these. Now, what is the difference between LOD and LOI? LOI is a term that emerged early, I believe, in 2017, 2018. And that term refers to the level of information. Previously, we were talking in BIM in the level of detailing first, and then we started talking about something called level of development. And it was still referred to as LOD. But later on came the need for information, and people found it very important to discuss what is the level of information required. And for you as a developer, you will have to set specific standards for each project stakeholder. For example, if you're working with a consultant, you might need to ask them about the information that will be provided in the model, and not only a model. If you only ask for a BIM model, you will get anything. You might get a high quality model or a low quality model. But more importantly, you might not get any information at all. You might not get any more information than the geometrical information that you're getting. However, if you ask for specific information requirements, you'll be able to specify who is the manufacturer, for example, for this element, or what is the U value rating for this element. If we're talking about a window or a wall, what is the actual material used here? And what is the thermal transmittance value in for this building component? Does it affect our energy analysis? Does it comply with authority regulation? All these are information that could be easily extracted from the model only if you request it. So the level of information that you're requesting from a designer, of course, is different than the level of information that you request from a contractor. For a contractor, it might be totally different because you're preparing actually this model to use it for maintenance or for operation. If you're doing that, then you might be asking them, who is the manufacturer for this? What is the warranty period for such element? And all these information are actually recorded into your model. It can be recorded in your model only if you request it. Revit as an authoring tool, as an example for authoring tools, I understand, of course, that you're using Revit as an authoring tool in Al-Futain, as I've been told. And Revit might not have all this information as parameters, but you can actually create a set of shared parameters where you can add your own specific per organization information and parameters that you can fill or ask consultants and contractors to fill for you. Now, the information that we can go with, it goes as deep as you want. It depends on your standards. This is an example that Al Ruqay company did it for the Red Sea development. I've been involved in the project a couple of years ago, and we did the project that included all the information that the Red Sea company requested. And you can imagine how many parameters they were asking for. It was more than 75 parameters for each element that we had to fill for each specific construction element. Of course, for the main and important building elements that will be maintained and must be stored, the information related to it must be stored in the model itself. And this means when you select an element, you'll be able to see at the right side more information about this element. What are the specific properties of this specific element? Who is the manufacturer? What is the warranty date? When was it actually installed? When it is due for maintenance for the first time? All this information will be stored in your models. And this means you're getting a rich information out of your model and not just a pretty geometry or a nice 3D that represents your as-built status. The code at the right side includes a link for simulation video. You can actually scan this with your mobile and go to the website to see the simulation, 4D simulation we did for the building. The building was the headquarters for the Red Sea, the new headquarters office for the Red Sea Development Company in Amluj. Shared parameters is the way to add these information. So if you want to add specific information, either if you're using it for your design as internal parameters, or if you're using it to publish it to a specific employer requirement, you can actually add it through this part. You will see this in the Manage tab in Revit, and you can actually edit the parameters. This is a list of parameters that we are actually using in the office in X-Architects. And we use these parameters to make sure that we have all the information we need if we need it for schedules, for any level of detail that we are issuing. Later on, after you assign these shared parameters, you can assign them to specific elements in the model. And based on that, you can start filling them for each element based on the project specification and the selection of materials for such elements. BIM for construction also enabled new technologies to be used. We can always see in the news the 3D printing of such and such building, or the prefabricated construction methods that is being more and more involved. And of course, in construction, fabrication has been used for many, many years, and it has been used for different levels of building. You could either have minor components that is fabricated and then assembled on site, or probably a full building unit, or a full building itself fabricated in a factory and then shipped to site. This is also an image of the world's largest 3D printed building done by Apis Core, and you can see that this has been also powered by Autodesk because it's significant for them. They are actually empowering part of this technology and making sure that it's as smooth as possible and as efficient as it could be. For construction also, you will need to know about verification technologies. And for verification now, we have so many ways of verifying if the information has been communicated right and the building elements were constructed in the best way possible, or if there is any tolerance for mistakes in construction. And there are mainly 3 ways to do that. We have 3D scanning, which works with laser scanning. It creates point clouds, and there are many solutions by 3D scanning companies that will enable this 3D scanning even for mobile devices. So you can actually handhold a device and move with it throughout the site, or even mount it over a helmet and move around the site freely to scan the building while you walk and notice what is happening there. Later on, you go back to your office and you get the 3D scanning output, and you analyze the differences of the actual construction with your BIM models. There is also the benefit of 360 photography, and that is also another very good solution that we're using for supervision in X-Architects. And this enables us to create 360 panoramas of all the spaces that we have on site and make sure that things are reviewed by relevant people. We can send this to our office team and make sure that they have the most updated information on weekly or monthly basis as required. The third element is artificial intelligence recognition. And this is becoming a new trend now, because artificial intelligence is becoming so powerful that it actually allows for automatic recognition of specific elements. We have seen solutions that will allow artificial intelligence even to spot errors in construction and problems like rust or leakage only by artificial intelligence, that will go through photos that you take from site and analyze them automatically to spot any problems that the AI can spot according to its programming capabilities. One of these solutions, and that is a very interesting solution that I have seen recently, is a program that is called Open Space. And Open Space in this example is a powerful way that will allow you to walk through the site with a 360 camera that is mounted on your helmet or handheld, that you can hold it high with your hand, and then go through the site normally as you would do. While you're walking, the device is actually capturing all the information. I believe it captures 2 images per second and uploads this information directly to the cloud, where it is linked to the BIM 360 model that you already have of your building for comparison. And this is the beauty of it. you do not have to interact or change things or set up things in a certain way for this to happen. Based on the BIM information and the GIS location information of your building and orientation of your camera, the AI system is able to recognize which part of the building you're working on, which level you are on, and where is the relevant model part in that. And that makes it very easy to compare what is happening on site in relation to your BIM models or your information, design information that you created in the first place. Moreover, this is also related to dates. So you can go back in history for the imagery that happens on site. You can go back, let's say, a month or two, and see where this problem originated, or if there was something wrong in construction a couple of weeks ago. You can actually see the progress of site and the progress of construction throughout time as per the walks, the amount and duration and duration of these walks. The AI in some cases is also very smart, that it can quantify elements only by looking at images that you capture through your walks. And this means the AI system is able to recognize which element it is, whether it's a drywall, a ceiling, a duct, a pipe. It will actually recognize what element it is, and then start comparing the quantity of the executed work to the what has been in the quantities itself. There is a link to a very interesting video you can view from this barcode. If you scan this with your mobile, you'll have access to this link immediately. And the power of this is, with the help of AI, we're able not only to recognize problems in construction, but also to track progress that is very hard to do in a manual way, and it cannot be very accurate. The form of AI reporting is in this form. As you can see, you will get a percentage of completion for each element. Right now, this technology is really new, and it's being used by a few major players in the field. But it's evolving, and I trust it's going to evolve in a better way to cover all building elements. So until now, they're working on the drywall engine. So the AI system is able to recognize if this wall is in the framing stage, or if the drywall has been fixed already, or it has been taped or painted. This means you will get actual tracking every time you walk through the site. And you will get such nice reports done automatically by the AI system. Now, the last part of our presentation is BIM for facility management. And for that, I would like to show you a few examples of what you can actually do with BIM for facility management using the rich information that we talked about. It is very important initially that you plan for your own success, because consultants and contractors might not know what is relevant to your team, what it means for you, and what is the most important information that you need. And this might mean that you change the way consultants and contractors work with you. You might ask them to change from coding systems and elements in such way that might not be very important or very relevant to you, to something that is more user-friendly to your team. This is an example of how you could use this naming system. You could use the first two letters, for example, for geolocation to locate which city this building is on, and then which building location in which exact town it is. And then in this example, it's AM for America and then CA for California. And building number. Sorry. This could be your building number to identify which building it is. And then which floor number, the asset ID. This could be something that you agree on for variable air valve or something else for HVAC or a pump. Any information for such asset that might be required for maintenance team later on. So you agree on the asset ID and then the asset number. With this in mind, you could come up with a strategy for naming all the elements in your BIM models that you will request from contractors and consultants working with you to follow. And that is happening through your policies that you create for BIM. Once you set that and your consultants and contractors start following the same, you will get the information you need for maintenance. So you have to plan it in the beginning to make sure that you get the actual information that you need at the end, and not just BIM models that are not used by anyone. The coding of assets is an important part, as we talked about. And of course, you know about coding like barcodes that is used for retail components and assets in a retail company. In the retail industry, coding is very important because it enables you to easily recognize things. It provides you with mobility and flexibility because you scan something with your mobile and immediately recognize what it is. It also decreases the amount of data entry errors because there is very little margin that you will scan something and get a different result. It also enables the maintenance technicians to quickly find problems, inspect which equipment it is, and get the relevant information that they need to perform their work in a better way. It improves the productivity of your team, and it gives you a quick return on investment. So it's really such an important way of coding things and making sure that everything is organized. You know how many assets you have in such building you want to maintain, and where are the location of each and every asset in such building or property. These are a few examples of solutions that are integrated with BIM. We can see BIM 360 Ops that has been done it has been created by Autodesk. And BIM 360 Ops is actually integrated with BIM 360 for construction or Autodesk Construction Cloud. So again, you can get information directly from your model. And the benefit of such solution and similar solutions is it is very user friendly. It depends mainly on using mobiles instead of using computers. So people on site, technicians and supervisors can easily use their mobile to extract information, scan a barcode or a QR code, and get the relevant information that they need, immediately create a ticket for maintenance, for example. Even users can do that. So you could have a simple code in each retail shop or in each room if it's a hotel, and just instruct the team member to scan that code to get the information and location of that specific place without any effort from his side. This will help you to create plans for maintenance. So you will get a plan in place. Let's say you have periodic maintenance, that must happen, let's say every 2 months, 3 months, and the technician or the supervisor will receive alerts on his mobile device to maintain this specific equipment on that specific date, so he knows exactly what needs to be done before problems happen. The workflows and notifications for such systems is customizable, so it depends on your organization, and you can actually set these workflows and processes by yourself and by your team in cooperation with such corporations and solutions. You also get real-time reports and dashboards for what is happening on site. How many tickets did we receive? Maybe we're getting too many problems with this property, so that property has a specific issue in electric currency and electric current, and we need to fix that problem to avoid more problems in the future. So you will get these real-time reports based on location and based on your property, and also linked with your model and drawings that you're using as a digital asset, a digital copy of your property assets. With that, I believe we've come to the conclusion of the presentation, and I would like to hear from you. If you have any questions, I'm happy to answer them. The QR code is for connecting, so if you'd like to connect or discuss anything later, let me know.